Okay, so phi 2 is over 3 by 3 system. So where you have 3 variables now. So we have x, y, and z. So we're first going to kind of look at what those solutions look like. So that's just objective A. That'll take us just a minute. And then checking ordered triples. So they're not ordered pairs anymore because there's 3 of them. So ordered triples. And then solve. So we'll get through A, B, and C today. We'll do D and E tomorrow. So first of all, we have visualizing these solutions in 3 dimensions. So 3 variables, there's 3 axes, 3 dimensions. So your x-axis is showing it's right here now, and then y is here, and then z is going up. Okay, so it's 3-dimensional. So if you look at this ordered triple here, this 2, 3, 1. So it's 2 units along x, 3 units along y, and then 1 unit up, like up in the air on z. Okay, so you're not going to have to graph, so don't freak out too much if you have a hard time seeing this. But there are 3 axes. So what we're looking at then is not just the intersection of lines, but the intersections of planes. So our solutions can look like this. You will have to be able to label these pictures. This is on page 517. So they're kind of hard to draw, so you might want to just note the page number. So if you take 3 equations with 3 variables, then that's like having 3 planes. And if they intersect just at 1 point, that's a unique solution. You could also say independent, and I would accept either one. I'm not going to add any more words to these. So for these pictures, these words here are the only ones you have to know. Then you have 2 types of dependent systems. You have linear dependence, which means they intersect, but not just at a single point, they intersect at a line. Okay, so that's where they would intersect. So points are all true for any points on this specific line. And then you have coincident dependence, which is where they all 3 overlap. This is like your infinitely many solutions, your 0 equals 0 true statement. That's what the coincident dependence is. Okay, then you can have no solution, or you could also say inconsistent. I would accept that as well. And that is where they don't all 3 intersect at a single place. Like 2 of them can intersect, but there's no place where all 3 of them intersect. Okay. All right, so that's just the visualization. That's what they look like when you were to graph them, or just what their solutions look like. Okay, now let's just check to see if the given order triples are solutions. So this is like the checking part of the solving. So here is the system, okay, and then I'm checking each of these ordered triples. So it's not saying that negative 452 goes with just this equation. That's not what it's saying. The system is attached. I have to check these ordered triples into each equation. So what I'll do is I'll plug negative 4, 5, and 2 in for x, y, and z. And I have to make sure it's true for all three equations. To be true, to be a solution, it has to be true for all three. To not be a solution, it just has to be false for one. Okay, so let's check this one. So I'm going to plug in negative 4 for x, 5 for y, and 2 for z in my first equation. So all we're doing is just typing that in. So does that equal 9? Yes. Okay, check the next one. So 5 times negative 4 minus 2 times 5 minus 2. Does that equal negative 32? Okay. And now negative 4 minus 5 minus 2 times 2. I want to know if that equals negative 13. Yes? Okay. So negative 4, 5, and 2 is a solution. Okay? Do the same thing for your second order triple. So just take it one equation at a time. So does this one equal 9? Yes. Does this one equal negative 32? No. So I can stop there. I don't even need to check the third one. No. Not a solution. Okay. Questions about that? So that's the checking part of the solving. So if you're solving and you get an order triple, plug them back in. Check to make sure your answer is right. Now you don't have to show all of that. A lot of times you can just type that in your calculator to check. But that is how you can confirm that your answers are correct. Okay? All right, so let's start solving. So I'm going to have to find 3 values. Since I have x, y, and z, I'm going to have to find 3. All right, well, when I have one equation that has just one variable, then starting off, this is pretty easy. I have 3x equals 6, so that tells me that x is what? 2. Okay. Well, now I have an equation that has just 2 variables, so I can plug 2 in for x and find y. So I'm going to plug 2 in to what equation? Yeah, the second one. Okay. So you can subtract 8, divide by -1, or 8 minus what gives you 3? Y has to be 5. Okay? Now that you know x and y, plug those values into the top equation and find z. So you'll plug x equals 2 in again, but this time you're going to plug it in here. And then you'll plug 5 in for y, and then we can find z. Okay? Combine your like terms. Subtract 7, so that's -8. So z equals -1. Okay? Write your answer as an order triple, in order x, y, z. So parentheses 2, comma 5, comma -4, parentheses. Okay? So these problems are not too hard. They just get kind of tedious, okay? So this was the shortest one that we'll have. It's when you have one equation with one variable to start off with. The others get a little bit longer. Okay, so just make sure you're working carefully, so don't accidentally miss a negative at the very beginning, because then that will throw everything off. Okay? So let's look at another type. So I still have 3 variables in that first equation, so I'm going to have to find x, y, and z. Okay. I see that I don't have an equation with just one variable, but I have 2 equations with just 2 variables. So I can do just regular elimination with those 2 equations to find x and y, and then I can plug those values back into the top one to find z. So I'm just going to do normal elimination. Would I eliminate a variable just by adding or subtracting? No, so I have to multiply. I think it'll be easier to multiply just one equation. I want to eliminate y's. So what would I have to multiply the top equation by? 2. So this is -2, so I just have to do 2 here. So then I get opposites. So that's 8x plus 2y equals 2. Okay, so let's just add down. 5x equals 10. X equals 2. Okay, put that back in. And you can go back up here or the second part that you have. So 4 times 2 plus y equals 1. Subtract 8 and I get y equals -7. Okay? Plug in x and y into the top and we'll find z. Careful when you substitute n with a negative out front. So that's -2, which is just -2, plus -7 plus 5z equals 1. So plus and -7 is just -7. And combine your like terms. Add 9. Divide by 5. We should get 2 again. Alright, write your order triple. 2, -7, 2. And you can always plug those back into your original 3 equations to check. Okay, questions so far? Okay, so let's look at now when I have 3 equations and all 3 equations have 3 variables. So this will take a little bit of space. Okay, so keep that in mind as you're writing your notes. So I just need to focus in and I need to eliminate one variable at a time. Okay, so I want to somehow get down to 2 equations with just 2 variables. So that's what I want to work towards first. So I'm going to take 2 equations at a time. What looks like the easiest variable to eliminate? The y's. And that's taking the first 2 equations, right? So I am going to just look at these. And can I eliminate y just by adding or subtracting? Yeah. So let's go ahead and do that. So I just eliminate one variable at a time. So 5x plus 1z equals 2. Okay. So I'm going to put that to the side, that equation. And now I want another equation. I want to get another equation that just has x and z in it. So I have to take 2 different equations. One of them will be the same, but I can't take the same 2. I want to take 2 different ones. So let's say I'll do these 2. Okay. So now I have 4x minus y plus 3z equals 3, and 3x plus 2y minus z equals 4. What variable do I want to eliminate? Y, because I eliminated y here, so I have to eliminate y here. Can I eliminate y just by adding or subtracting? No. What should I multiply the top equation by? 2? Okay. Make sure all 4 terms there are multiplied by 2. Okay. Now I can add, because I have opposite signs, so I add. That's 11x plus 5z equals 10. Okay. So now here's my second equation. Okay. So let me note. So make sure you keep your notes organized. Okay, so where these have come from. Okay, 2 equations, 2 variables. You can do normal elimination. So what I do is I have to do elimination 3 times. So I had to do it 2 times to get rid of 1 variable to give me my 2 equations, and then I'll do normal elimination to find x and z. Okay, let's get rid of z. So what should I multiply the top equation by? Yeah, let's do -5. So then okay. So that is -14x equals 0. So x equals 0. That's okay to get a 0 as a number. Let's plug that back in. So 5 times 0 plus z equals 2. So 5 times 0 is just 0, so you get z equals 2. Okay, now that you have 2 of the variables, go back to any of the 3 equations to find y. So plug 0 in for x, 2 in for z. Two in for z, and 0 in for x. So 0 plus y minus 2z equals -1. Okay, so that 0 just goes away there. So y of 4 equals -1. So y equals. So write your answer in order, x, y, z. So that is 0, 3, 2. Okay. Questions about that? So just keep your notes straight, work carefully, don't make simple calculation mistakes. They do take a little bit of time, okay? But if you understand how to do normal elimination, then this should go okay for you. Tomorrow, don't put yourself up, just a minute. tomorrow we are going to do the special cases. So like the dependent ones, the linear dependent, coincident dependent, and then the no solution, the inconsistent ones. So we'll work on those tomorrow and look at a word problem. So